vara en minut lag på det. Where is somebody actually watching it? I've got no idea what I'm doing. I'm trying to figure out how much lag it is on this thing. So, yeah. Hello there, Mr. Me. I really have no idea how much lag there is on this. Yeah, there seems to be about a minute's worth of lag. Alright, you can hear typing. Well, I'm not sure now. It's screwing everything up, dropping quality. Yeah, this is a bit screwy. It seems to be working. What type of keyboard? The keyboard is an Acer 6312. It's semi-mechanical. It's got like membrane switches, but mechanical buttons. Righto. Lots of people are saying that it works, so I suppose that's something. It's giving me a yellow stream health thing. I've got no idea what that means. Okay, your viewers might be experiencing minor issues. 10 to 15 seconds, really? To me, there's about 1 minute 20 seconds of lag. If I wave my hand across the camera like that, it'll show up about a minute and a half after I do it. But if you guys say 10 to 15 seconds, I suppose that's good enough. Waving for George Atwell. Okay, Doogie, I'll try it, thanks. You're probably the expert. Okay. Waving for myself. And counting the seconds. Yeah, that's a lot better. That is a lot better. Thank you, Doogie. Shoe on head, no. I'm sorry, but if you don't believe that this is my bench, then I don't know what to tell you. Yeah, anyway. There really isn't much point to this stream. I was just trying to figure out if it works. I'm gonna be entering some data on this Breeze Audio TPA 3116. Yeah, 3116 amplifier. Just gonna be fiddling around with this distortion meter, trying to see the chat at the same time. There we go. Yeah, so I've just got the TPA 3116 connected up to the meter. It's currently putting out about 5 watts per channel, and behind here I've got a laptop power supply actually powering it, because this is, yeah, I think I made a video on it. It's a $20 amplifier with which runs fine off of a laptop power supply. So I want to figure out just how much power you can actually get by just using it with your bog standard laptop power supply. I already did all the testing on it, but I've redone my big sheet for entering data on this stuff, so I want to try that out. There's a lot of Excel magic going on. The component drawers were literally the cheapest I could find locally. Finnish IKH company makes them. They're really cheap crap. No, it's not sunny. In my basement, I've just got a giant set of lights. 320 watts worth of T5s. So there can be about 3000 lumens on the bench if I want it to be, but yeah, we've just actually got one running right now. I can't turn on all of them, will probably swamp out the camera. Oh no. But it's stupid right now. Oh, my cap. No, that's because I don't like light. I don't like light in my eyes, so I wear the cap too, just to get it away. Hello there. I love the Famicom, the Win Famicom. Major commenting guy. Yeah, I'm just gonna start measuring the amplifier really. It's a really long and drawn out process for this analog meter. Alright, Doogie, thanks for the feedback. Alright, so let's get to the amplifier testing. Still need to have a multimeter to actually measure the output voltage, because else we can't calculate the output power. I can even get that to show up on camera probably. Kind of. Nope, that's not gonna show. Not enough contrast. Oh well. The Twin Famicom, okay. Twin Famicom. What's the difference between a single Famicom and a Twin Famicom? Oh, this really isn't showing up on camera. Righto, data entry. Output level is 0.775 volts, as it's supposed to be. Now I've just got to enter everything. Starting at 50 milliwatts and 633 millivolts. I'm just waiting to see how the viewer count is going to drop a bit. Probably one person per minute until I'm down to like 1 or 2, because this reel isn't intended to be interesting. I just want to find out if it works. Understood. So for reference, we've got a 30 kHz high pass filter on this, low pass filter on this amplifier. Because if you try to measure the distortion of these Class D things with no low pass filter, they're just going to be noisy as hell, and you're not going to get proper measurements out of them. We've got 0.045% total harmonic distortion and noise out of this thing. On the left channel, I think the right channel is a bit worse on it. No, it's exactly the same. Anthony, yes it is, I just set everything up. I have not done any script, no nothing. I just wanted to find out if all the encoding stuff is working, and as long as people are watching, I suppose there's no point in ending it, because clearly then somebody's enjoying it. Say something controversial or start rambling on about politics or something. Twin Famicom, do tell what is the appeal of a stream like this, because I honestly wouldn't be watching this myself. Guy in front of the computer entering data while rambling. No man, Trump is an idiot. Jesus. Vote Sanders. If you're American. Otherwise just enjoy the carnage. 100 milliwatts, 894 millivolts. There we go. Left channel 0.038%. Right channel 0.037. And if you can't see, this is a little left-right channel switching box I've made, so I'm just taking this to swap between measuring the left and right channels of the amplifier and the test. Toby, nothing's really gone off, nothing's exploded, and this is unlikely to be very interesting. I'm just gonna keep entering data until I'm done entering data about this little amplifier here, using the distortion meter there, the multimeter there, which neither of which you can see because my webcam is horrid. Mm. 500 millivolts, left channel, milliwatts, and that's 2 volts into 8 ohms. So we want to swap input ranges. And we've got 0.028% total harmonic distortion and noise on the left channel at half a watt per channel. Right one. .026. American politics is the least of our concern at the moment. Our impending exit remaining in the EU is our main focus at the moment. Well, I don't know what we are referring to right now. Toby, I'm not using a VU meter. This is a HP339A distortion meter. It measures the amount of distortion in a sine wave, down to about minus 80 decibels. Well, that's nice, Ray. Yeah. Live performance is not my main thing. So again, I'm gonna warn everybody that this is probably going to be a bit boring. Left channel, 1 watt, 2.83 volts. Left channel, 2.83 volts. We are over 0.03% distortion. We've got 0.04% exactly. And our right channel. There's quite considerable channel mismatch on this amplifier, so I keep having to readjust the volume every time. Yeah, this is what I saw the last time I was testing this amp. Right now, just as it's approaching a couple of watts, one of the channels starts getting really distorted, while the other one keeps going on a lot better than the other one. And let's see, the left channel had 0.04%, and the right channel now has 0.024%. So we've got half as much distortion on the right channel. Sasquatch, that doesn't really sound very true. Obama doesn't seem to want much at all, really. PC Tonto, yep, I'm from Finland. Given your name, I'm assuming you're as well. And yeah, just to be certain, I am from Finland. The country of Santa Claus. Left channel. 2 watts, 4 volts. Swapping ranges to a 10-volt range. And we've got 0.067% THD plus N on the left channel. The right one with no more major channel mismatch. We've got just about 0.03. Thank you, Anthony. And an odds, Finnish metal is better than Norwegian metal. I don't care what you say. We've got Fintroll. Left channel, 3 watts. 4.9 volts. There we go. And we've got 0.095% distortion. Right channel, 3 watts, 4.9 volts, 0.035. So the left channel is just outclassing the right channel at the moment. I'm glad to hear it, Toby. It was those audio stations were really weak because, like, I ordered two of them at the same time from the same supplier, but they're manufactured that far apart and entirely different devices. Later on, I do. No twin Famicom. It's sitting on a heap of just normal CD cases. For a reason, and that's because I've got these. You're not going to be able to see them because of these shit resolution, but I've got little needle probes sticking out up and down from the amplifier, which is going to this box. And the reason for that, like I've just soldered needles onto the end of these cables, is to be able to shove them into like really tight little speaker outputs together with the leads for the dummy load. Because I want to, like, there's no point probing the amplifier from the dummy load. I have to probe just at the amplifier output, else I'm going to have all this crap coming into the wires to account for as well, and it's just going to give shit results. Anyway. Left channel. 4 watts, 5.66 volts. And we have more than 0.1% distortion. We've got 0.105. Right channel. 4 watts, 5.66 volts. And we've got 0.042. So we've got more than twice as much distortion on the left channel right now. Got an LDPS. What can do with the batteries are good, but apparently ideal for electric. Toby, the batteries of a UPS are fine, and scooter, just put them in a scooter if you want to, but lead acids are shit at cyclic use. You're probably better off just getting some cheap LiFePOs off of eBay. I recently got a 10-pack for like $20, 18650s. Gonna be interesting to see if they're any good. I've got these little flashlights which take 18650 LiFePOs. No, Anthony, I'm just unemployed for the most part. Anyway, left channel, 5 watts, 6.32 volts. And we've got 0.1125. Well, it's just called 0.113%. Another big issue with testing amps like these, this device has a tendency to overheat. So when I'm doing these tests and, producing more and more heat the further I go, it's going to start overheating, and that's very likely to skew the results once I start getting up towards the peak power. And I'm not really sure how to compensate for that. I could just take, like, one data point every few minutes, but that would feel a bit stupid because the amplifier wouldn't be at the same temperature for all the tests, but it's almost impossible to make sure it's at the same temperature. Got to blow my nose. Spring analogies. Anyway, right channel. No, hang on. Yeah, right channel 6.32 volts or 5 watts. And we've got 0.048% distortion. Left channel 10 watts, 8.94 volts. And we've got a lot of distortion. 0.14%. Right channel 10 watts, 8.94 volts. 0.064. Dustin, I'm glad to hear it. And hello, Mrs. Abidji. Left channel 20 watts, 12.65 volts. I probably should try and get these measurements done relatively quickly before the amplifier overheats on me. Yeah, in this particular amplifier, the channels are really mismatched. I mean, this is obviously a cheap Chinese copy of a chip. So they haven't really gotten it right. 12.65, and we've got 0.175% THD plus N, unweighted with a 30 kHz low pass filter. And on the right channel, we're actually on the same scale now. We've got 0.115. And left channel 21 watts, 12.9, and it's really shooting away now. At 21 watts, we've got... It might actually be starting to clip due to the low supply voltage. Let's see, we've got 0.43. And on the right channel, 13 volts. Or rather, 12.96, 21 watts. We've got 0.33. I'm pretty certain the amplifier's starting to clip now. Who's been convicted of drunk driving on your wall? That's my old Swedish history teacher, who was a really bad teacher, and I hated him. So when I saw that he'd been convicted in the newspaper, I had to save a copy. Anyway, left channel 22 watts, 13.27 volts. Definitely clipping now. We've got 1.6% distortion. Right, channel 13.27 volts. God, this is finicky. 1.6%. Left channel 23 watts, 13.57 volts. I usually do this power versus distortion test up to about 10% THD plus N, then I just don't bother anymore because it's just obviously hard clipping. $13.57, and we've got 3.2. Right channel, 13.57 volts. 23 watts, and we've got 3.3% distortion. And 24 watts, 13.86. This is probably gonna be very hard clipping. Oh no, we're not above 10% anyway. 13.86, and we've got 5.3%. Right channel, 13.86 volts or 24 watts. And we've got 5.2. Uh, 25 watts or 14.14% left channel Breeze Audio TPI 3116 running off of a 19 volt laptop power supply. $14 volts, and we've got 7.4% THD plus N. Santiago, I'm testing this Breeze Audio TPA 3116 amplifier. It's a $24 thing off of AliExpress, and it's running off of this laptop power adapter back here. So it's running off of a 19 volt supply. And I'm just figuring out how well it performs with, just a generic 90 watt laptop power adapter, because that's probably what you want to use with this thing. So we're at 25 watts, 14.14 volts, right channel. And we've got 7.3%. It's obviously just hard clipping right now. Yeah, now my I have to redo this spreadsheet, the power section for every amplifier test, since I need to have a different power range, and I've clearly not really anticipated going beyond 25 watts on this one, because the next step up is 80 watts or 25 volts. And we've only got a 19 volt supply voltage, so it wouldn't ever go above 19. So I'm just going to end it there. It starts clipping at about 20 watts per channel, which is really not too bad at all. That's about what you'd expect. Well, Guyabi, if you're eating pork dumplings as a vegetarian, I don't think you're a vegetarian. So now moving on to the distortion at rated power tests. So this amplifier is rated for 21 watts according to the datasheet. So let's see what we get. Actually, how hot is this thing running? Yeah, it's not running too hot already. When I tested this before, I was could barely touch this heating because it was running so stupid hot. Goyabi, accepting reality is the only path towards happiness, man. Literally, whatever might be is what might be. If you can't accept that, then you're never going to be happy in life. Take that from someone who lives in his mother's basement. Anyway, we want to push 21 watts out of this, and that is 12.96 volts of a left channel. 12.98. That's close enough, and we've got... Well, we've got a lot of distortion, actually. Yeah. This is an issue with testing these amplifiers with external power supplies, because it's clipping now. It's obviously clipping due to a limitation in supply voltage. But I've only got a rating for the power output for a specific value. So when rating this thing, should I turn it down until it's not clipping anymore, or should I just take a data point here? The issues you have to resolve as a internet reviewer. I'll just take a data point here. It's what's interesting. We've got 0.4%. I've come to think of it, that actually is within spec, since it's specified for 1% at its rated power. Go figure. And no twin Famicom, I live in my mother's basement. Since I haven't been able to get a very steady job ever, I haven't been able to afford to move away. And we've got a pretty big house, so it works out pretty okay. I'll technically live in both the basement and one of the rooms upstairs. I've just got my giant workshop in the basement because it's mouldy and horrible and cold and nobody else wants to be here. You can't tell in the videos, but I'm usually freezing my nuts off in here. Even during summer, it's like 15 degrees Celsius. Anyway, right channel, 12.96 volts. And we've got 0.36. So it's actually within spec on both channels as far as the peak power output is concerned, so there you go. I know for a fact it cannot handle this continuously because it'll overheat, but nobody ever runs their amplifier where it's continuously at its rated power anyway, so who gives a toss? It's actually pretty good. There are some other condemning factors about this thing though. Anyway, now we're moving on to the distortion at rated power. 4 ohms test, 1 kilohertz and 32 watts is its rating. So I'm going to switch this load to 4 ohms. And we're going to move our power meter to... I'm going to have to calculate that. I've got a little piece of software on this computer. It's called MISC-L, which can do all kinds of really useful electronics calculations and some mechanical stuff too. If anybody's interested. It's got an entire page for Ohm's law, so I can just put in resistance for power 32, and I get the voltage and current just like that live. We want 11.31 volts to get 32 watts into 4 ohms. .31 volts, left channel. There we go. Just a bit too high. The volume control is a bit fiddly. 11.31, there we go. And we've got actually less distortion than we had at 8 ohms. Despite putting out a third more power, we've got 0.29 on the left channel at 32 watts into 4 ohms. And the right channel, I think that's the better one, yeah? So we've got 11.32, 3.1. There we go. Yep, considerably less distortion of the right channel. We've got 0.17. Reese, if I had a garage, I would be using it as a garage. You really should be using that, man. Anyway, if somebody's just joined, I'm measuring this Breeze Audio TPA 3116 mini power amplifier, $24 off of AliExpress. I'm just gathering data for a review I might do of it, and that's what you're watching. Get into the chat. I'll like say things at you if you say stuff in the chat, maybe. Also, this is not particularly interesting, probably. So you're going to the power at rated distortion test, 8 ohms, 1 kilohertz, 1% distortion left channel. We want to be in the 3% distortion full scale range. We want the load to be at 8 ohms. We want to be at the left channel, and just turn it up until we've got 1% distortion. There we go. 13.14 volts. And that's what? Uh, 21.58 watts. And the right channel. $13.175. $21.7 watts. That's a 19-volt supply. Enjoy yourself, Sasquatch. Guyabi, most of my stuff is picked out of the trash. I've got some friends in industry who usually supply me with like the distortion stuff, the power supply stuff they're about to toss out. And yeah, that's basically it. I bought a multimeter, I bought a hot air station, that's about it. Dumaload, homemade, just eBay power resistors, reasonable tolerance. Scope, free trash picked. The DSO was also free trash picked. It had broken controls on it. I had to repair it. It was out of warranty, and it's a Rigol DS1102E. So it's actually a pretty crap scope. They're not very good if you consider it from an industrial standpoint. It's not worth it trying to repair them. It's just cheaper to buy a new one for like $200, $300. Anyway, amplifier, 4 ohms, 1 kilohertz, 1% distortion, left channel. And we've got 12.075 volts. That's actually quite a lot of power. That's 36.45 watts. Right, channel 4 ohms, testing for 1% distortion. Let's assume some similar performance. Then, yep, we've got 12.1 No. Oh, we've got the exact same value, 12.8. I'm just gonna put down 36.5 there too. It's close enough. Moving on to the clipping power tests with both channels driven into 8 ohms. And the first test is for 0.3% THD plus, and this is usually what I use to call the peak power, the real clean output power, where it's just clipping very, very, very slightly. So let's see what our maximum clean power is. For 0.3% distortion into 8 ohms, we've got 4.94. Give me a moment, Dan, I'll tell you. That was 12.94, I think. Was it 12.94? Yeah, probably. Yeah, that makes sense. 20.93. 20.93 watts. Dan OSI, we are testing this Breeze Audio TPI 3116 mini power amplifier. It's a $24 job off of AliExpress. TPI 3116 based, if you want to look up the datasheet. Little aluminium case, very nice looking actually. Pretty bad design on the inside, but hey, that's what testing is for. I'm running it off of a 19-volt laptop power supply back there to just emulate a common use case scenario for this thing. It's everybody's got a laptop power supplies, and when you got the last generation's cheap Chinese Class D amplifiers, you were looking at the like TA2020 based things like a Li-Pi, and those would go up in smoke if you connected 19 volts to them, so you were limited to like 5 watts per channel into 8 ohms. But this one will clearly do quite considerably more at about 21 watts. Yes, Goyabi, I don't think this one is available anymore actually. Not this exact model, but I'll just type it for you. I think that'll give you a few hits. Like the Breeze Audio seems to be just the case. This particular case is called the Breeze Audio, and then a lot of different Chinese manufacturers make innards for it. Like these two boards, they both go into the same case. These two are dual TPA 3116 boards. They've got 2 chips on them, and they are configured to a 2.1 solution. As you can see, they just fit perfectly in like that. So I'm going to test these two at some stage. I just haven't gotten around to it since it's such a bother measuring this stuff. And I've been sitting here for 50 minutes blabbering on, and I'm not even half done. Anyway, right, channel 8 ohms, 0.3% distortion. We're probably going to look at just about 13 volts for this channel as well. Yeah. 12.997. Yeah, we've got 21 watts. No, Sudos, you're not my big brother, I'm sorry. I'm voluntarily sharing my workshop with you. I could stop you from watching me any moment. So don't you try. Anyway. 8 ohms, 1%, THD plus N. Left channel. A lot of these tests are a bit redundant on this amplifier since, I'm actually just going to take results from earlier because it's rated at 1% distortion, so I've already got the 1% figure further up in the spreadsheet, and that'll be 21.6 watts and 21.7. There we go. In the spreadsheet I'm filling out, my amplifier test spreadsheet, I've got just a lot of different tests for different power levels, essentially. And it's mostly optimized for higher end amplifiers that have ratings like 100 watts per channel into 8 ohms at 0.012% or something like that. And they don't actually give you a clipping power figure. So that's why I've got in this spreadsheet, I've got a 0.3% distortion figure, a 1% distortion figure, and then a 10% distortion figure as well. On top of the rated distortion figures. So there's a lot of data that goes into this amplifier test report. What's your opinion on SDK amplifier ICs from the 80s? They're pretty okay. They don't usually survive. There are two things which kill them. One is shorting the output, the other is bad supply capacitors, or bad, they have these little bootstrap caps which are like 47 micro or something, and when they go bad, they tend to go up in smoke. I'm sorry, Anthony, you haven't missed anything interesting. And yes, das OSI, that is entirely true, and that's why I'm doing the test on the laptop power brick. Anyway, 8 ohms, 10% THD plus N left channel. I want to go into the 30% distortion full scale. And now we are really clipping hard into 8 ohms, and we've got 14.6 volts on the left channel. That is 26.645 watts. Right channel, TPA 3116 Breeze Audio. 10% distortion. Right channel. 14.6 volts. And lo and behold, it's exactly the same. Which is what you'd expect since we're just voltage clipping. So 26.6 watts. And moving on to the 4 ohm tests for the various distortion levels. So we've got 0.3%, 4 ohms, left channel. Let's see what we've got. Probably going to be around 12 volts. Whoa, it's overheating on me. Yep, it's overheating on me. You couldn't see that, but the distortion just went through the roof for a moment there. I know. It's not overheating, actually. It's definitely not overheating. That's weird. What on earth happened there? The distortion just went insane. It went like pegged the meter. And well, let's just try that again. No, it's fine. That was weird. We've got... yeah, no, something's going weird now. Something's going really weird. Oh, no, I'm in the wrong range. I should be in the 10 volt full scale range for this, because... when you go between ranges, when you have the bottom of a range, the meter actually goes pegs to the right, and then it goes all the way to the left to indicate that you're out of range. So that's what That's what I was doing wrong. We've got 8.56 volts on the left channel at 0.3%. And that is 18.31 watts. 18.32 even. Twin Famicom, yeah, but if it's yeah, Sony tend to be okay with the caps in those, but often, even though they are Chemicons and so forth, those 80s caps are not known for their reliability. But if it's just some generic SDK amplifier you've got, I mean, who cares if it goes up in smoke? It's not going to be a high-end amplifier anyway. Sorry to say. Right channel, Breeze Audio TPA 3116 mini power amplifier, 4 ohms. And we've got, yeah, the right channel is performing a lot better at 4 ohms, a lot better. We've got 11.92 volts. That's going to be like twice the power. Yep, 35.52 watts. So the left channel gives you 18 watts, the right channel gives you 35 watts. There you go, Chinese quality. Hmm. 1% figure already have up here. $36.5 and 36.5. So 10% THD plus N, left channel 4 ohms. We've got 13.27 volts. And that's 44 watts into 4 ohms. That's clipping distortion. And the right channel, 10% distortion, 4 ohms, same story. $13.34 volts. Ever so slightly more. $44.49. I'm gonna fetch my mouse, be right back. I'm getting tired of this touchpad. Get some more 2.4 gigahertz noise into the air. And got to remember to save the spreadsheet. And now we're moving on to the output impedance tests of this Breeze Audio TPA 3116 mini power amplifier, $24 off of AliExpress. Goyabi, yeah, usually the board is about $20 and the case is about $20, but for some reason this one was $24 including case and board. So I don't know. Seems the Chinese just wanted to be extremely cheap for that one. Data Helg. If you've got a link for that, I'd be happy to give it a look. Goya B, I'm live streaming. I'm expecting to say the same thing over and over again. Anthony, you really need to define working for me to be able to answer that question. I've been playing around with stuff since I was like 10 and I'm 23 or something now. But I've been doing stuff like semi-seriously for maybe 5-6 years, something like that. I mean, it's a, sleep. I'm a nerd at heart. All I've ever done in my spare time is this stuff, I don't go to parties, I don't drink alcohol, I don't do any of that. I just sit here and be a nerd. That's what I do. And still I don't manage to make any money off it, so there you go. That's very nice, Carlos. Thank you. Righto, testing the amplifier. So we want to be at... We're testing the damping factor, so we want to be at 8 ohms, and we want to be putting out half power, and our output power is about 20 watts. We want to be at about 10 watts, which is about 8.94 volts. Left channel. For this test, I only use the multimeter since we're not interested in the distortion, we're just interested in the voltage we're putting out. And that's about 8.9 volts, so that's our loaded voltage. Gonna enter that into the spreadsheet. 8.924. And now I'm gonna go into differential mode on there and turn the load off, and we've got 0.29. And that gives us an output impedance of 0.269 ohms, or a damping factor of 30. Let's do the same thing for a right channel. About 8.9 volts. Loaded voltage 8.909. Differential measurement, load off 0.284. That gives an output impedance of 0.26 ohms, or a damping factor of 30. So both channels are matched on that part. Sup to you too from UK London. Sup to you from... Where am I? I'm in Hammarland, Finland. It really doesn't... You really can't say Hammarland very well in English. Hammarland. I'm in Hammarland, Finland. Angelio, I'm testing this Breeze Audio TPA 3116 power amplifier. I'm just entering data on the computer, testing a lot of different parameters, and just gathering data for an upcoming review. And I shouldn't say that because I never get around to actually filming the bloody amplifier reviews. But the gist of it, for anybody who's just joining, is that this is a $24 amplifier. You don't seem to be able to get it for $24 anymore. They cost a lot more now. It's running off of a 19-volt laptop power brick there, and it's putting out about 21 watts per channel into 8 ohms. Goyabi, yeah, I'm from the Swedish-speaking part. Åland is actually one of the few places in the entire world which is uniformly unilanguage by law. Like, our law says, we are Swedish speaking, we are not bilingual. It's really weird. Right, so 8-bit impedance test for 4 ohms. So I'm going to put the load at 4 ohms. We want to take that out of differential measurement. We want half power at 4 ohms, which is about 16 watts per channel, something like that, which is the same as 8 volts. Left channel. Eight volts, thereabout, 7.985. Well, let's just do 7.98. Differential mode, load off, 0.514 volts. And that gives us an output impedance of 0.275 ohms, or a damping factor of 15. Well, let's do the same thing for the right channel. 8 volts, just about 8 volts, 7.98. Managed to strike the same exact spot. Differential measurement, load off, 0.514. So that's obviously going to give us the exact same result, since we are entering the exact same number. So 0.275 ohms output impedance into 4 ohms on the right channel as well, measured at half output power. How do you feel about living in Finland but speaking Swedish? I don't care. I sincerely do not care. And it's basically Sweden anyway, this, except we don't have the horrid immigration policies, but we're the quite opposite. We are extremely xenophobic, so it's a very nice place to live. Extremely low crime rates. Extremely nice everything, usually, actually. Very socialist, high taxes, expensive in the supermarkets, since it's a little island nation, basically. Importing stuff is retarded because of some stupid tax reasons. But beyond that, it's really good, and I don't care about the language. Anthony, no, I don't speak Finnish. Dasarc, yes, a damping factor of 30 is quite bad. You usually want it to be about 100. But yeah, this is an extremely cheap amplifier, so I mean, you can't expect anything much better. Basically, all these cheap Class D or car amplifier style devices will have a damping factor between like 10 and 40, thereabout. Every car radio ever made is going to be similar to this. You know, it works. It's not super hi-fi, but it works. How come you speak so well English? Well, that sounded stupid. I've just been on the internet for a very long time. I speak internet, so to speak. Anyway, we're moving on to the unweighted noise floor into 8 ohms at a input shorted. So we want to take those out. We want to install our shorting plugs. We should try to get away from it. These are just RCA plugs which I've cut the end off and soldered together. Shorting plugs. So that we definitely have no signal going in. So we get the true noise floor off of the amplifier. Left channel. Have you been to the UK before? No, I've never been further than Denmark. I would like to go to the UK sometime though. Got a couple of friends there. But I'd be afraid to get stabbed in the street, because that seems to be quite popular over there. even though you keep banning knives, which is a bit silly. Unweighted noise floor, left channel 30 kHz high pass filter, low pass filter. So what do we have? Unweighted noise floor of. Should I? Yeah, I think I should. I don't remember how my spreadsheet works. I don't remember if I'm supposed to enter in negative dBV or if I'm to enter it in microvolts, but I think it's microvolts. So we'll try. We've got 250 microvolts. Yep, that worked, and that's minus 72.04 decibel volts. Which is about the same level as the LePi, actually. Not hi-fi by any means. Very non-hi-fi. Let's do the same thing for right channel, just flick the switch. And we've got 220 microvolts. Or minus 73.15 decibel volts. Steppen, kind of a pre-university type of high school thing. I did 3 years. It wasn't a very good education, though. It was mostly just jerking around and reading on stuff if you felt like it. But yeah, I do have a formal education in this field, but not at a university level, no. How do import taxes go in Holland? Horribly. We're a separate tax zone from Finland and from the EU, so we basically end up paying twice as much import tax on everything. So importing stuff is a bit expensive sometimes. Unless you go through a lot of paperwork in order to have the tax removed prior to the product entering the EU. And on Chinese stuff, it doesn't really matter since there's usually no import tax added anyway, but anything from like the US or the Western world, especially within Europe, where they already added a value-added tax, it's really hard to avoid paying the tax twice. You have to have the seller who sends the item remove the tax before they send it, else you're screwed. Anyway, time to do the noise floor at the volume setting that's required to produce a full-scale output signal. So that means we've got to put some more signal into this and turn it up to about 12 volts. That'll do. That's about as loud as it'll go. There we go. And back over shorting plugs to measure the actual noise floor. And now we've got a noise floor of 480 microvolts. Or minus 66.38 decibel volts. On the right channel we've got 430 microvolts. 435 even. Or minus 67.23 decibel volts. Twin Famicom, no, I don't do tubes really. I mean, you can get that horrible thing that EEV blog reviewed, probably. Anthony, it's kind of EU, like it's part of the EU politically. Hello there, Peter Kiss. We are having a look at this TPA 3116 amplifier from China and testing the performance of it. Anyway, Anthony, like, Ireland is a part of the legal territory of the EU, so we follow that legislation, but we're not part of the fiscal territory. So any money-related thing, that's what we do on our own. And that's why all taxation is all screwed up. Jamie Koski, do you play with microcontrollers? To some extent, when I need to. I don't like programming, I hate computers. But sometimes you need to do it, so yeah, sometimes I've done some programming. But yeah, not to any large extent anyway. Oh yeah, entering these microvolt figures into the spreadsheet also gives us our signal to noise ratio on this Breeze Audio TPA 3116 mini power amplifier. And the signal to noise ratio, as it is usually rated, it would be 94.41 decibels if the volume is all the way to the bottom, or 88.75 decibels if the volume is set to the level required to produce the maximum non-clipped output. Yeah, that's like the numbers you want to compare if you're looking at some other amplifier. You know, that's what they're gonna put in the manual as the signal to noise ratio. So this is, you know, low 90s, which isn't very good, especially for a power amplifier this weak. Peter Kiss, no, I haven't tried to build a discrete Class D amplifier. Like, building things for just the novelty of building things is not my thing. I just build things if I have a need to build a thing. I don't actually like. I don't. I'm weird. I don't like making stuff for no reason. I need to have a reason to make stuff, and I do it more for the reason than for the stuff, so to speak. What might you expect to see in your test results from using the laptop charger versus any other power supply? The difference with a laptop charger is that it's going to have a relatively high output impedance, relatively, due to the long lead. It's a switch mode power supply, so it's going to be a bit noisy. And it's a 19 volt roughly power supply, so it's going to be like 18 to 19 volts, so that's going to limit the maximum output power. I'm also going to measure this thing with a 24 volt supply using my big industrial power supplies, which you cannot see. And that's just going to probably give the amplifier a slight, like using the proper high-end power supplies is going to give the amplifier a lower noise floor. It's going to remove any ground loop issues you might have in a normal situation, and it's going to give it more peak output power since we've got a higher supply voltage available, and it might cause some more overheating issues since we're going to have a higher power dissipation inside the actual amplifier. Knuckles, my UPSs always work. So go ahead, yeah, that's the difference you're gonna see with a proper power supply. Now, keep in mind, I'm comparing it to like really proper industrial power supplies, which are not switch mode power supplies. They are transformer isolated and extremely well regulated. So, like, just switching to from a laptop charger to some like industrial 24 volts power supply, you know, a little Meanwell installation thing, which is going to be like this big, is not going to give you much advantage aside from the higher supply voltage, giving you a higher peak output power. Anyway, just a few things left to measure on this thing. Right, we're gonna measure the gain of the amplifier with a volume set to maximum. Actually, I'm gonna test the -3 decibel point first. So we want to hook our input signal back up to the amplifier. And we want to adjust for half output power on the left channel, which is gonna be about 10 watts or 9 volts. There we go, that's about 9 volts. And we want to adjust the distortion meter to measure the input level. 30 volt range, that's fine. We want to have a relative measurement. That's a great feature on this 339A. You have this relative measurement functionality where you can just trim a certain signal to be your 0 dB reference. Then you can just adjust whatever parameters and get a direct reading in decibels, voltage decibels, what your difference in level is. I haven't ever seen a multimeter which has any functionality. This Brymen certainly doesn't have it. It just has some weird dBm functionality which is useless for this. Does your state somehow support photovoltaics on houses when you're up for so far from north? Yes, they do to some extent. But you need to have some really specific panels, and you need to have a grid tie system and all. It needs to be really boring and professionally done and so forth. Anyway, half power, left channel, we want to measure the low cutoff point. So 100 Hz, we're at minus nothing. Minus 2. It's just... Yeah, I'm gonna put that as a 9 Hz minus 3 decibel point. I already did this test once and it was pretty much the same on both channels, I remember. So now we want to do the high frequency cutoff test. 10 kilohertz, 20 kilohertz, down 2.8 decibels. So I'm going to put it like 21 kilohertz. Maximum output frequency. And now we're going to do the same thing for the right channel. So I want to go back to 1 kilohertz. Adjust the relative level to be exactly minus 4. And low end. Now that's going to be 9 Hz as well. And I'm waging my best that we're going to have 21 kilohertz limit on this one as well. Yep. And I'm pretty certain it's not going to make a difference if we do that at 4 ohms. So 1 kilohertz, set our relative level to minus 4 decibels. Let's go to 10 Hz again. Yeah, it's exactly the same. 20. No, hang on. We've actually got... At 4 ohms, it's actually rolling off quite considerably early at the high end. We're down 2, 4, 6 decibels at 20 kilohertz. That's not very good. So at minus 3 points. Minus 3 decibels at 13 kilohertz. That's silly. 13 kilohertz. You sound intelligent, thank you. You should probably go and study. No. Studying is stupid. I don't like doing things which requires you to follow certain protocols. I'd much rather make up my own protocols. Which is why I quit school and went on to be unemployed in my mom's basement. Do you like lifts or elevators? That's an oddly specific question. I suppose they are uplifting. I don't know. Don't usually use them since I don't live in a city. So I suppose I'm quite neutral towards lifts and elevators. No elevator has ever caused me any harm. I usually take the stairs though. Anyway, right channel, left channel. Set our reference, 1 kilohertz. -4 decibels, there we go. Let's just do the high end right off, since that's what seems to be interesting. So at 10 kilohertz, we're down 2 decibels. Yeah, at 13 kilohertz, we're down 3 decibels again. Wow. So this amplifier is really sensitive to 4 ohm loads. As far as high-end frequency response is concerned, anyway. I mean, 20 kilohertz, we're down. Yeah, we're down 6 decibels at 20 kilohertz on both channels. So this thing doesn't like 4 ohm loads, although in my experience, these little Class D things generally hate 4 ohm loads, no matter what you do, because they're just built for 8 ohms. That's it. Because it's cheaper to do that way. It's not my high pass filter playing, low pass filter playing around, is it? Nope. Still down by a lot. I'm not ignoring you, Twin Famicom, it's just that I'm rubbernecking between my laptop over here, the test gear over there, and the chat over there. So I'm just doing more things than a man is supposed to do. Also, the mouse for the chat computer is like 2 meters that way, so I can't scroll up in the chat to see what people have said. Anyway, now it's time for the boring part, which is the frequency response test. So we want to be at half, power left, channel 1 kilohertz to set our reference. That's close enough. We want to have an 80 kilohertz high pass filter. Now, when you're talking about Asperger's, I'm about to say some horribly offensive things that I'm not gonna say. I'm such a nice guy. My YouTube persona is a nice guy. Well, that's not actually the case, probably. And we're at -4 decibels, reference at 1 kilohertz. So let's just do the 20 hertz test. And we are at -0.8 decibels. And we've got a distortion of 0.36%. Yes, Twin Famicom, I don't doubt that you do. Like, that's like that's a thing. I seem to attract people with Asperger's for some reason. Like 80% of the people I know have Asperger's, and believe it or not, I don't. I've actually been tested because my parents thought I had it when I was a kid. Anyway, 100 hertz test. We are at 0 dB. And we've got 0.05% distortion. Hang on, did I get the last test right? I don't think so. No. I'm doing something wrong now. I'm definitely doing something wrong now. These measurements are all stupid. There's a thing about this 3398 distortion meter. It's got a bit of an issue where the frequency on the dials isn't really right according to either its own internal oscillator or any other meter, and that can be a bit confusing. And Twin Famicom, I wasn't intending that to be an insult or anything, just a statement of fact. Like, it's just one of those odd tidbits of information that I've noticed. I tend to have a lot of autistic friends. Hey, Goyabe, that's a very fair point. Stepan FI really would do not belong at a university, trust me. What am I doing? I have no idea what I'm doing right now. Testing the... Yeah, distortion at 20 hertz on this thing. It doesn't actually have that much. Yeah, it's got... That's weird. I've got no idea what I did wrong there, but I entered the wrong data into the spreadsheet. 0.3. Is that actually right? Yeah. This thing's got a lot of distortion at a really low frequency for some weird reason. They're not pushing it into fucking 4 ohms. What am I doing? I'm doing everything wrong. Hey Goyabe, you are... Du är en annan finlandssvensk. Right. 100 hertz test was okay. 1 kilohertz test. And that should put us steadily back at the -4. I've done something wrong. My reference is screwed. Oh yeah, what's... Ah, Christ, I have the load set to 4 ohms for a couple of tests, so I have to redo everything, redo the entire frequency response test. Blech. Anyways, I want 100 hertz. We are down 0 dB. We've got Oh, that's... Now I know what I'm doing wrong. I've got the wrong input range. I'm confusing everybody, including myself now, aren't I? There we go. Right, now we're back on track. Right, CPA 3116 Breeze Audio Amplifier Frequency Response Test Take 2 into 8 ohms, not 4 ohms. 20 hertz. We are down 0.8 decibels, and we've got 0.12% distortion. Hey, there's nothing wrong with Windows NT. 100 hertz. And this is probably at minus 0 dB. Yes, indeed. And we've got 0.12% distortion. One kilohertz. That's obviously going to be 0 dB, and we've got 0.12% distortion. Moving on to 10 kilohertz. We've got minus 0 dB. And lots of distortion. 0.76% distortion. $20 kilohertz. We are at minus 0 dB. But we've got even more distortion. We've got 1.3% distortion. That's quite considerable distortion at high frequency, I must say. Moving on to the right channel, gonna do the same exact thing. 1 kilohertz, adjust our reference voltage. There we go. And now we want to move. Might as well just take the data point for 1 kilohertz right away. That way I won't have to do it again. And we've got 0.61% distortion. Twin Famicom, I'm surprised you'd think there'd be anything good about Windows 10. Anyway, 20 hertz, Breeze Audio TPA 3116. Right channel, and we've got minus 0.8 dB. at 0.51% distortion. No, 0.851% distortion. That's a considerable difference. 100 Hertz. I'm betting 0 dB. Distortion 0.53. No, 0.853. Already. Why are you doing measurements with different eBay Class D? I'm just doing the tests to do the test because no one else is doing the tests. It gets plenty of views on YouTube. I mean, not everybody's got a proper distortion meter, so I'm just doing a bit of community service. For the most part, these amplifiers just end up on the shelf. There isn't really a market for them around here, and it makes no sense to sell them on eBay since nobody would buy them. I should just sell them to random subscribers for like half price. Cut my losses. Anyway, I would want to move on to the 10 kHz test. Input level, right channel, 0 dB. We've got a lot of distortion. We've got, wow, 0.76%. Yeah, that's actually the same as the left channel. And 20 kHz finally. Zero dB. And we've got 1.27% distortion. So this amplifier really isn't very good at the high end. Really isn't. It hates it. Now we're moving on to the gain test. We want to turn down the input level so that we're not exploding everything when we turn it to the max volume setting. Left channel. Let's do about half power. About 8 volts or thereabouts. There we go. So now we are at -2 there. And the input level is... let's see, 10 decibels, 20 decibels, 30 decibels, 28, 27, 26.4 decibels of gain. And the right channel. Let's see. we've got 10 decibels, 20 decibels, 30 decibels, minus... No, what am I doing? I'm doing everything all wrong. I'm getting a bit too tired to be testing amplifiers. Right, channel gain test. We've got 10 decibels, 20 decibels, 30 decibels. This makes no sense. I think I measured the other channel wrong actually, because I'm getting 31 point 246. 31.6. Let's just redo the test on the other one to make sure I'm not screwing everything up. $10 decibels, 20 decibels, 30 decibels. Yep, 31.6. So that's actually quite a lot of gain on this thing. 31.6 decibels. That's almost the maximum that the chip is able to perform, actually. Oh well. Time to do channel gain mismatch at the worst possible setting. Oh, that's annoying to measure. That's annoying to measure. Yeah, both channels are having exactly the same gain at the maximum volume setting, as you'd expect, since, you know, they're supposed to be identical. But the important thing is how well the volume control tracks across the range, and I haven't figured out a very good way of actually measuring that. Since you'd really need a 2-channel measuring setup to do it. So it's really annoying if I'm to hook that up and measure it. I'd have to take a huge amount of data points and just to keep swapping between the channels across the range to see where the difference is the biggest. Oh, that's just really annoying. Really annoying. What I could do would be to connect the distortion analyzer between the channels. I'm uncertain how the ground is set up on this thing. It's supposed to have several different ground zones, and I think the signal generator output is actually floating. Twin Famicom, like, what I want to do is measure the specific maximum gain mismatch which requires me to basically measure the difference in output between the channels while sweeping the volume control up. And that's most easily done, if you've got a two-channel spectrum analyzer that you can just calculate the difference between the two inputs directly. But I think I should be able to just measure between the inputs, between the channel outputs, since the ground of the output is separate from the ground on the input of this meter. So I'm just going to try connecting across the outputs. What that happens is that it goes up in smoke. Right, let's see if it explodes. No. No, I'm not connecting the ground. Yeah, I'm connecting the ground to the output, and it's working fine. So I can actually very easily measure the difference in amplitude between the channels. Sweet. Dodged that bullet. Das also, yes, I could, but I'd rather just have a reading directly in decibels, which is what the distortion meter will do. Else I would obviously just use a multimeter directly. But it's annoying to have to calculate the difference in decibels, accounting for the output signal as well. Goyaby, I don't really care too much for GNU Linux. I mean, it's got its uses. I don't have any particular use for it. I run Windows Server and everything. It's just a lot easier to set up. Let's see, how should I set this up? We can get a pretty good... Oh man, I'm too tired to be thinking about decibels and math and stuff. It's never been my strong side. Yeah, measuring channel mismatch this way isn't going to work very well. It's going to work very well at all. because I've got no proper reference. Well, I've got the reference of VA. Oh. This is supremely annoying. I really need a 2-channel meter in order to calculate this, and I can't be bothered setting that up. Das Ossi, my first name is Ludwig, with a W. Yeah, fuck it, I'm not gonna bother measuring the channel mismatch because it's just gonna be huge setup. I have to use a spectrum analyzer, and that means I've got to connect up my computer. And doing that with a lifted ground system like this bridge tied amplifier is just a major pain. In fact, it wouldn't even work at all. Yes, that's correct, Das Ossi. So we're not gonna test the channel gain mismatch on this thing. I'm not gonna bother with efficiency either, because I don't have a easily connectable shunting meter to put in series with the laptop power supply. Although I suppose I could just use a different power supply. So that basically just leaves us with the out-of-band noise left to test. So I'm gonna have to fire up. I flipped my cap, okay. I didn't think about it. I keep adjusting this because I've got an itchy head. Now let's just fire up this thing to test for the out-of-band noise. Want to install the shorting plugs, volume to minimum. Plug in my fancy new €7 probe. Shouldn't be using the ground clip for this, but it's going to be pretty obvious what's the noise generated by the amplifier and what's noise generated by EMI. Because I know we're looking for a roughly 400 kilohertz noise signal on this. Times 1 probe. Left channel. Is this set up properly? Coupling, AC. Bandwidth limit off, no digital filter, nope. It's probably going to be... Oh god, it's about 50 Hz hum. No, that's... It's counting something at 7 megahertz, and that's definitely not right. This is looking really screwy. twin Famicom I got it from TME. It's a Handtech probe. I think it's 80 megahertz or 50 megahertz, something like that. It's cheap. It's pretty good quality though. That would be tme.eu. Okay, I'm gonna have to put on the 20 megahertz low pass filter because this is looking horrid. It didn't help anything at all. Yeah, there we go. Now it's starting to trigger. Yeah, I want to turn on some averaging because there's going to be quite a bit of noise in this signal since there's just other amplifier noise going on as well. And now it's starting to look like something. Now we're getting somewhere. Yes. We've got a nice looking 400 kilohertz sine-ish wave. At about... yeah, what's that going to be? 8 millivolts. So that's not bad at all. Let's make that 10 millivolts actually. Anthony, I'm not hoping to achieve anything really. I mostly just wanted to find out if it's worth doing at all, if it would work. There's no real master plan behind this. None at all. I mostly just wanted to be a bit less bored while doing the amplifier measurements because this is extremely boring to do. If I can just yap on about random crap to a crowd of people, that makes me feel more accomplished for some reason. Alright, I barely has any out of band noise at all. Or it's very sporadic. I think it might be very sporadic. Yep. Very sporadic at 11 millivolts. Well, if you guys like watching me do random stuff live, and I suppose I'll do more of these. It's weird though, I sincerely do not understand why you guys would be watching this. Because I myself would be bored out of my mind watching a stream like this. Now I'm gonna redo the test on the other channel with the same measurement parameters since Yeah, averaging doesn't work very well. We've got 15 millivolts actually. Background entertainment. No, I suppose that's a fair point. Like any kind of podcast. You're just here for the chat. That's a fair point. Bringing nerds together from all around the world. Oh crap, I've entered my data incorrectly. I'm getting formula errors. Ah, got to correct this. There we go. Everything looks great. Oh, so I'm like music to your ears, Anthony. Should I sing for you? No, I'm not going to subject you to that. Data hell, if you're bored at work, then you are doing work wrong. But I suppose that's why I'm working 2 days a week for a very poor pay. But I do enjoy my work. Anyway, let's see if I can get this spreadsheet onto the camera. Actually, let's see if I can set up... if I can set up a desktop stream screen capture thing. Please don't what? Please don't get the spreadsheet on the screen. Come on, that's what we've been working on this entire 2 hours time. Dan Ossie, I work in electronics repair. Little local shop. I fix consumer electronics and industrial electronics and basically anything. Now, please don't sing, yeah? Give me money, else I'll sing for you. Give me cash. You've got 10 minutes to make a donation to this channel, else I'm going to sing for you. That was a joke. No, I'm not going to sing. I'm going to try and get some screen capture on and make sure I capture as much private data as possible because I haven't planned for this. Let's see. Now, where the hell did I save that file? Oh, I found my file. Let's see if I can even open it on this computer. The amount of folders I have in my pictures and data folder structure is stupid. Okay, let's see if I can add a source. Add global source. Oh, hey, I think we've got a window. Can I? Holy crap, that almost seems to be working. Oh yeah, it's even showing up in the stream. Fantastic. Let's see what we have in this. This is the big thing about this spreadsheet. This entire executive summary box is automatically filled from all the fields down there. All of these are just giant formulas. Or just cell references with a lot of formulas to make averaging and stuff. So what's the summary for the Breeze Audio TPA3116 amplifier then? Well, we've got a noise floor of 457 microvolts, or minus 66.8 decibel volts. A native band noise at 13 millivolts, a signal to noise ratio of an average of 89.2 decibels, a gain of 31.6 decibels, a damping factor of 30, a frequency response of incorrectly entered data. I fixed that. But I forgot to save the file. Yeah, whatever. A channel mismatch of I didn't enter that, an efficiency of I didn't enter that, and a power output of 20.965 watts per channel into 8 ohms using the 19-volt laptop power adapter. So that's not too bad. It's certainly beating the LeapI. Certainly beating the LeapI. And for the price I paid for this amplifier, it's certainly a very good device. I must admit that. Even despite its issues with one channel having a lot more distortion than the other one, it's a very competent amplifier. And I'm real surprised that it doesn't have more out-of-band noise than it does, because the filter in it is very, very spartan. It doesn't have a single component more than it needs to. Yes, Dasossi, the LeapI is getting old. Well, the TA2020 chips have been old for a very long time. They're among the first Class D chips to ever come out on the market, really, and achieve any kind of market success. So, yeah, you really need to consider that. But yeah, either way, this thing doesn't come anywhere near a proper hi-fi audio amp. I can just bring up a reference for you, since I've got, if it's capturing on the camera, I've got all of this stuff is various amplifier test stuff I've done. So let's just compare it to, I've got the Marantz 2215. This is using the old version of the test sheet, but it's going to be good enough. So this is like a low-end 70s amplifier. It's rated for 15 watts per channel, I think. Yeah, 15 watts per channel. And we've got, considerably lower distortion at the rated output power. I said 0.043% at 15 watts per channel, and this one had 0.4% at its 21 watt rating. Are you going to edit some of this footage into the upcoming review video? No, I'm not. I'm not even certain if this is recording, actually. I don't think I'm going to make this public for later viewing either. I mean, it's just 2 hours and 16 minutes of... I don't know. Well, I suppose there's no downside in making it available. I mean, I suppose it's got podcast appeal, like somebody said. And Twin Famicom, I wouldn't say that it's really unfair to compare the TPA3116 thing to an old Marantz, because the Marantz is 40 years old. By every right it should be inferior. Oh god, now I've done something silly. I want to close that one. I do not want to save it. Goyaby, my internet connection, I've just got ADSL with NXM, so it's like 18 megabits down, 1.5 up, something like that. You can get really cheap fiber here, but I haven't, since, this is my mom's house. And I'm not gonna pay... Like, there's a connection fee of about, I think it's 2,000 euros. And then it's like nothing per month. But I'm not gonna pay for the €2,000 connection fee. Yes, that's also somebody spent a lot more than $20, but that was a long time ago, and this particular one came out of the trash. I paid nothing for it. Of course not Twin Famicom, but this Marantz is actually a very poor performer. It's not a very good amplifier. It's extremely noisy, mostly if we look at the noise specs. It's got the 3.5 millivolts of noise. It's extremely noisy. A real hiss maker. But it has got a superior frequency response. It has got lower distortion at mid-power levels. We're talking 0.404% or so across most of its power range, where the cheaper... I lost it. The cheaper amp has more distortion. It's just increasing more per unit output power. Where the hell did that thing go? Read only, thank you. If we look at the distortion, it will increase quite linearly here. It won't, like on a good quality amplifier, you expect it to start out kind of high in this general area, then it should drop at around half a watt, be extremely low, all the way until it starts clipping. And this one just kind of increases gradually as you increase the output power, so that's not very good. And yeah, the channels are extremely mismatched. If you look at the Marantz, it's got that characteristic I was talking about. It's relatively high here in the low power region, then it goes to 0.05, basically stays there until it starts clipping. So it's very linear, even though it's a very old, crappy amplifier. And if we... let's just bring up the... Let's see, I've got a couple of really good ones saved here. Do I? Well, let's do the Yamaha AX590. This is a stupidly good amplifier. It starts at 0.0092% distortion at 50 milliwatts. And then it basically just drops from there to like 0.005 and stays there until it starts clipping. This is basically the ideal amplifier. This is what you want to see. Do the P22000. The P22000 is actually not anywhere near as good as the AX590. The AX590 is it's just the cleanest amplifier I've ever tested. We can bring up the P22000 just for fun. Let's see. Here's a test from about a year ago. So the P22000, it will do a lot of power output. I mean, it starts clipping at about 260 watts. But it's actually got better figures than I remembered. 0.0032% at 220 watts per channel isn't bad. But the P22000 is quite noisy, as you can see. At 50 milliwatts, we've got 0.03% distortion. If you compare that to the AX590 with 0.0092, that's because the AX590 has a much lower noise floor. I think I've got noise figures for both of them. Yeah, the output impedance of the AX590 is stupid. We've got a damping factor of 1,500. It's just insane. And the unweighted noise floor of the AX590 is 39 microvolts. 39. And if you compare that to the P22000, you've got an output of 140 microvolts. Which isn't too bad, but it's not super good. Not super good at all. So, yeah, in short, the P22000 is just mostly a PA amplifier. It's relatively noisy, very high power, very robust. It still has a very good damping factor at 369, though. I don't have any other fun ampli. Yeah, somebody mentioned the ugly Dackling. That's a little sound card thing I made. Let's see if I can get that in frame. I just took apart this cheap USB headphone set, which looks like that, and I put a little 3.5mm output on it, and it's a useful little device. But the performance is abysmal. I think I did a couple of spec trims on it. Let's see. Spectrum noise A-weighted. Yeah, we've got, like, this is a sound card, and we've got an A-weighted noise level on the ugly Dackling of minus 82 decibel volts. Like, that's a noise floor you'd expect out of a power amplifier. You know, that's worse than the Yamaha AX590. So, for a sound card, this is just extremely bad. Extremely bad. But it's a little USB sound card. It works. Anyway, I think I've done pretty much what I intended to do with this stream, so I think I'm gonna end it here. And you guys, I don't know if this chat stays up after I close the stream. I actually have no idea. But I'm certain you guys can figure out IRC channels and stuff. I mean, probably half of you come from the Geek Group, right? Hashtag the Geek Group at, what's it, irc.geekgroup.org? Something like that. I don't know. Yeah, thank you guys for watching. Enjoy yourselves. Now I just need to figure out how to stop this thing. Jesus. I need to stop streaming there. Goodbye.